Hi, I'm Matt, and in this video we are going to go over how to do math with numbers in scientific notation. Usually you'll have a calculator for this, but on the off chance you don't, it's useful to know how to do it by hand. So first, we're going to go over how to multiply and divide numbers in scientific notation. So our first step is to multiply or divide the coefficients as we usually would. And then we're going to round that to the correct amount of significant figures. Then we have to deal with our exponent. So if we're multiplying, we're going to add the exponents. And if we're dividing, we're going to subtract the exponents. And that will give us our new exponent. And now, sometimes we're going to have a fourth step, where if our new coefficient is greater than or equal to 10, we're going to have to move the decimal till it's less than 10, and then increase the exponent by the amount of places we move the decimal. Now, this may sound confusing, but as we do examples, it will become a little clearer. For our first example, we are going to do 1.2 times 10 to the negative second times 2.4 times 10 to the eighth. So the first thing we are going to do is multiply the coefficients, which are the 1.2 and the 2.4. Doing that will give us 2.88. But 2.88 is three significant figures. Both of our terms only have two significant figures, so we're going to round that to 2.9. Now, for our next step, we need to figure out what the exponent on the 10 is. And since we're multiplying, we're going to do the negative 2 plus the 8. We're going to add the two exponents. And that will give us 6. So currently we have 2.9 times 10 to the 6th. Our last step is to check that our new coefficient is less than 10. Since it is less than 10, there are no more steps, and this is our final answer. For our next example, we are going to do 3.6 times 10 to the 7th divided by 1.2 times 10 to the negative second. You'll realize I have parentheses here. That's because when we divide, we have to make sure that we show we're dividing not by the 1.2, but by the whole 1.2 times 10 to the negative second. Even when you have a calculator, it's important to watch your parentheses. Now, the first step we are going to do with this problem is divide our coefficients. 3.6 divided by 1.2 gives us 3. But that only has one significant figure, while both of our coefficients have 2. Therefore, we have to make 3 two significant figures by making it 3.0. And then we have to find out what our new exponent will be. Since it's division, we're going to subtract our two exponents and do 7 minus negative 2. You'll realize we have a double negative, which makes a positive. So that becomes 7 plus 2, which will give us an exponent of 9. Therefore, our final answer will be 3.0 times 10 to the 9th. No further conversion is necessary since 3.0 is less than 10. For our last example with multiplication and division, we are going to do 9.3 times 10 to the negative 4th multiplied by 8.8 times 10 to the 9th. So as per usual, our first steps will be to multiply our two coefficients. And that gives us 81.84. That is 4 significant figures. But both of our original coefficients only had 2 significant figures, so our answer could only have 2 significant figures. So we're going to round this to get 82. Next, we're going to find out what our exponent is by adding our two exponents, since it's multiplication. Negative 4 plus 9 gives us 5, so we get 82 times 10 to the 5th. Here's where step 4 comes in. We can't leave a coefficient greater than 10. So we're going to have to move that decimal one place to the left to make it 8.2, which is now less than 10. However, when we move the decimal one place to the left, we have to increase the exponent by 1. So our final answer will be 8.2 times 10 to the 6th. Now, we're going to go over the steps for adding and subtracting numbers in scientific notation. We can't add numbers with unlike exponents, so we're going to have to convert the exponents to be the same. We do that by either decreasing the exponent of one of the numbers and moving that decimal that many places to the right, or we can increase the exponent and move the decimal that many places to the left. Once we have the same exponents, we're going to add or subtract the coefficients and then round them to the correct amount of significant figures. Then, we're going to bring down the exponent we converted to in step 1. And the last step is convert the coefficient to be less than 10, the same way we did with multiplication and division. Let's try some examples. For our first example, we are going to do 4.3 times 10 to the 9th plus 1.2 times 10 to the 8th. Our first step is to make our exponents the same. It doesn't matter which one we change as long as they're equal in the end. I'm going to make this 10 to the 8th. But since I decreased that exponent by 1, I have to move the decimal one place to the right. So this becomes 43 times 10 to the 8th plus 1.2 times 10 to the 8th. Now that our exponents are the same, we could combine our two coefficients, yielding 44.2 times 10 to the 8th. Now, to round this to the correct amount of significant figures, we have to round to the ones place, because that's where 43, our least precise number, is precise to. That gives us 44 times 10 to the 8th. Now we're almost done, but we need to convert this to proper scientific notation, which has a coefficient less than 10. So we're going to move the decimal one place to the left, and we're going to increase our exponent by 1. This will give us our final answer of 4.4 times 10 to the 9th. For our next example, we are going to do 7.6 times 10 to the negative 2nd minus 1.9 times 10 to the negative 3rd. I'm going to choose to change the negative 2 and make it negative 3. That will decrease the exponent. Therefore, I'm going to move the decimal one place to the right to give us 76 times 10 to the negative 3rd minus 1.9 times 10 to the negative 3rd. Now that our exponents are the same, we could do the subtraction, which will give us 74.1. Now, we need to convert that to the correct amount of significant figures. And once again, 76 is our least precise number, so we're going to round to the ones place. 1 tells the 4 to stay the same, so we're going to have 74 times 10 to the negative 3rd, since we just bring down our exponent. Now, once again, we're not in proper scientific notation. So we're going to move the decimal one place to the left and increase our exponent by 1. This gives us our final answer of 7.4 times 10 to the negative 2nd. For our last example, we are going to do 4.6 times 10 to the 2nd plus 6.42 times 10 to the 3rd. In this one, I'm going to increase the 2 to a 3. And when we increase the exponent, the decimal moves to the left. So we're going to get 0.46 times 10 to the 3rd plus 6.42 times 10 to the 3rd. Now that our exponents are the same, we could add our coefficients. Will give us 6.88. Now, our new coefficient is precise to the hundredths, and so are both of our original coefficients, so we do not need to touch this. This is already in the correct amount of significant figures. So all we have to do now is bring down our exponent, which is 10 to the 3rd. In fact, this is our final answer because our coefficient is less than 10. So our final answer is 6.88 times 10 to the third. Now that we've gone through some practice questions together, here are 6 practice questions I encourage you to try on your own. The first 3 are multiplication and division examples, and questions 4 through 6 are addition and subtraction questions. At this time, I suggest you pause the video, and the solutions will be provided for you on the next slide. The solutions are as follows, rounded to the correct amount of significant figures. Question 1 was 7.8 times 10 to the 9th. Question 2 was 5.6 times 10 to the negative 6th. And question 3 was 1.8 times 10 to the 5th. Question 4 was 2.51 times 10 to the 5th. Question 5 was 3.0 times 10 to the 6th. And question 6 was 1.4 times 10 to the negative third. Hopefully you got these. If not, feel free to leave any questions you have in the comments below, and I will get back to you as quickly as possible. Thank you so much for watching. Have a great day.